Today I'll be covering extrema and the first and second derivative tests. Extrema are the minimum and maximum points on a graph. So for example, a relative maximum is a point that's greater than all the points around it. A minimum is a point that's lower than all the points around it. And the absolute maximum and minimum are the greatest points on the graph entirely. The extreme value theorem states that on a continuous function in a closed interval, there must be an absolute maximum and minimum. Critical points are where f prime of x is equal to 0. And while they do not guarantee that a point is an extrema, they're a critical point because we need to make sure and check. The first derivative test uses the first derivative to find local minimums and maximums by observing how the sign of the first derivative changes at a critical point. So for example, at x equals 2, to the left, f prime of x is greater than 0, and to the right, f prime of x is less than 0. This means there's a local maximum as f prime of x goes from positive to negative at x equals 2. Conversely, when f prime of x goes from negative to positive, we know that there's a local minimum. The second derivative test uses the second derivative to find these points because f double prime of x, or the second derivative, describes concavity, or just the way a function opens up. So for example, in the x equals 2 region, f double prime of x is greater than 0, meaning it's concave up. And in the x equals 4 region, f double prime of x is less than 0, meaning it's concave down. And there's also the inflection point, which is when f double prime of x changes sign. Now to find local minimums and maximums, we first need to observe the concavity, or the value of f double prime of x. If f double prime of x is greater than 0 and f prime of x is equal to 0, we have a local minimum. And when f double prime of x is less than 0 and f prime of x is equal to 0, then we have a local maximum. Thank you guys for watching.